Hello viewers, my name is Raj and welcome back to my YouTube channel. So I am back again with a new video. This is a new video in complete placement preparation series, and today we will try to solve this problem with this rotate matrix or rotate image. On this is a platform. This is a problem on Leetcode platform. The number is 48 and this is a medium category problem. So let us understand what this problem wants us to solve. So basically we will be given an n cross n matrix. So you can take it as an image as well. Consider as an image as well. So this is an n cross n 2D matrix, and we have to rotate this image or this matrix by 90 degrees angle. So which is in a clockwise direction. And one more thing that we have to note is this whatever the rotation or the operation we have to perform it in place. So basically we cannot use an extra matrix. Even if we use the extra matrix, we have to somehow reflect the change in the original matrix itself. So it is up to you to if you want to use an extra matrix or not. So, but I personally believe that taking an extra matrix or taking an extra space is nothing but a wastage. And in practical terms, we are not allowed to use such that, because if I see in a real world scenario, let us say if I have a matrix of, let's say, 1 million cross 1 million rows and columns, and if I want to perform some operation, then I will create one more matrix which will be of same size. So that doesn't seem very feasible in terms of storage, right? So we have to somehow make a program which will do it in place. So let us take an example. So there is a very good example given over here. So let us take this as an input. So if we have input 1, 2, 3, 4, 5, 6, 7, and 9, the output should be 7, 4, 1, 8, 5, 2, and 9, 6, 3. So this is nothing but if you just rotate this matrix clockwise in a clockwise direction by 90 degrees, you will have this kind of output, right? So let us just take a step back and start analyzing how this output came, right? It seems very simple, but if you see it in a programming or logical way, how would you try to construct this kind of an output? Let us go and in some explore it widely. In this, so this is our input. This matrix is our input, and this is our output, right? So if I see clearly, what I can see is I have this row which has now become the last column, right? Similarly, the second row has become the second column, and third row has become third column, right? So this matrix is transformed into this matrix, right? So if you see if you are going to use a second matrix as an extra space, then it is very simple. That what you have to do is you have to start from the first row's last row's first column, and you start iterating it from this way. So you will have 7, 4, and 1. Then after reaching 1, you again start from the second column's last row. You have 8, 5, and 2. And then at the third column, we have 9, 6, and 3. So this is one way of simply iterating or just traversing the matrix, and you will have your answer. And to be brutally honest, in this kind of a problem where we have to deal with all the elements in a 2D matrix, the output is always n square. So that is something that we have to keep in our mind. We always have to use two for loop, two nested for loops. So this is which will be as a format of for, and you will have some condition, and then you have another for. So we generally try to avoid this whenever we are doing competitive programming, but in these kinds of problem you have to write them. So there is no alternative, and if you can able to think a better solution, then it is up to you. But mostly these solutions work because these are problems like that, right? So this is one way where we are going to use an extra space, and we will store this particular thing. So again, if I traverse this, and if I store this in the same matrix, then there will be a consistency error, because if you simply see, if I traverse this particular first column, and if I replace it with 1, 2, 3, if I replace 1 2 3 by that, then what state I will have? I will have 7 4 1 4 5 6 and 7 8 9. So you can see there will be 2 7 2 4s, and so there will be issues with consistency, right? So we have to we have to think beyond that. So let's go towards the ideal solution or solution that I propose. So we'll start with the basic thing. So if you carefully see, basically your first row becomes your first column, right? Similarly, your second row becomes your second column. Sorry, second last column. Okay. So what I was thinking is, let's transpose this particular matrix. So transpose is nothing but where your columns becomes your row and your rows becomes your column. So that is basically transpose. So if I transpose this particular matrix, if I transpose this matrix, what I have is 1 4 7 2 5 8 and 3 6 9, right? So this would be your answer after transposing. So transpose is nothing. I have done nothing. I have just interchanged these particular elements. And 8 and 6, right? I have only interchanged this. The diagonal elements remain the same. Diagonal elements are nothing but your 1 1, 2 2, 3 3, etc. are your diagonal elements. So I am, apart from diagonal elements, I have swapped all the this values. So this is nothing but 2 1 and 1 2. First row, second column, second row, first column. I just swapped these values. Similarly, you can swap all the values and you will have this particular state. Okay. So if you see this state and this state, there is something to note, that if you change the columns, interchange the columns, you will have your answer, right? So if I interchange this particular column and this particular column, what I have is 7, 8, 9. I will remain the the middle column as it is. So I have 4, 5, 6, and then I have 1, 2, 3. So if you see, you will have your answer. So what you have to do is, first you have to perform the transpose plus column swap, right? So this is column swap. So if you perform these two operations, and you will have your answer. So if I see in worst case, what time complexity of its transpose? N square. In worst case, ideally we don't go till n square, and for column swap also we take it as n square. And if I add these two, I always have n square time complexity, which is okay in this case. So let's try to code this thing and see if this code or this logic works or not. During the code, I will try to optimize that n square code so that in actual runtime we don't go till order of n square. We will always remain below that. So let's start with the code. So we don't need any variable or something like that, because we are going to do it in place, right? We just will only need the iteration variables. So I will have I, which will be going to iterate. I will need one variable to store the order of the matrix. So if I talk about square matrices, we always have the order. So order is nothing but n cross n. So where n is your order, right? So I will have n stored as a variable, because I will be needing that again and again. I will have the first for loop to iterate through the rows, the second for loop to iterate through the columns. So here is the trick. Since traversal operations, if I transpose any matrix, I only have to swap the non-diagonal elements once. Other than we don't have to swap it again and again and again. If I swap the half triangle or the half of the matrix, the other half will automatically be swapped, right? So what I'm saying is, if I only swap these elements will already is automatically swapped, right? So we'll only have to go till n by 2, right? So now what I have to do is, I have to access the elements I comma j. So, and basically I have to swap j comma I. So which is nothing but, if I have to swap the element which is at the first row's second column, I have to swap it with the second row's first column. So 1 2 2 1. So similarly, if I have I as the row pointer and j as the column pointer, I have to swap it with j as the row pointer and I as the column pointer, right? And similarly, I will assign the elements, respective elements. So for the this particular element, this particular element will be the value will be saved in this particular variable, the first variable, and then in the second I will have I comma j. So this will do the transpose for us. Okay, and if you clearly see, we are not going to up to n square, but we are going to be below that. So this was your transpose. So now I have to swap the columns, right? So for swapping the columns, if you see, I have the columns as the constant. So if I want to swap the first and the last column, I know that I have to stay in this column only, in the first column only, but I have to change the rows one by one, so that I can access that particular value. So here what I will do is I will have n by 2. So I will go only till the half of the matrix, and I will swap each and every value from the half. So the other half will already be swapped, right? Similarly for column, I have to go for rows. I have to go in detail. So I will have range n. Okay, so now I will simply write j of I, so which is nothing but if you carefully see, I have to iterate through all the rows. So I have used j pointer for row, and I have to keep the column constant. So I'm using I, which is as a column pointer in the outer loop. So outer loop will only be accessed once after n iterations, right? So that's the purpose. So this will take out the first column's first element. Similarly, I have to take the counterpart, which is the last column's first element. So what I have to do is I have to keep the row constant, but I have to change the column pointer to the last. So for that I will use n minus I. N is the total number of columns, and I will minus it with the current with the first the current I value, which is 0, and I will again minus 1 because the number of rows is because we are using 0 indexing, right? So we have to think about the indexes as well. So this, you have your first and your last columns of first value. Now have to interchange. So this is nothing but very easy, similar to what we have done above. So I have j, and then I have n minus I minus 1, and I have matrix of j comma I. Okay, so this is it. I think this will work fine. Let's try to submit this thing. Let's run it on the test case first, then we will submit if this is working or not. There is a syntax error. Let's see what's the error. Oh, I have to forgot to write in. So now this will work. The answer is getting wrong. Let's see where is the error. Sorry, I found the error. So the error is I to n. So basically what I'm doing is I'm doing the same thing. I'm just traversing the half of the matrix, but this is a better way. I think we were missing one of the indexes, so this will sort the thing. So for first index, I will go to 0 to n. So I will take the upper half of the first row. In the second row, I will go one element short, and then in the third iteration, I will go 2 elements short. Similarly, we will traverse the upper half of the matrix, and the second part will be fine. So let's run this thing. So this is accepted. Let's submit this code and see if this is working fine or not. So this is better. This is faster than 63% of the online Python 3 submission. So this is fine, and I hope you have enjoyed this particular video. If you have any doubts, you can ask in the comment section. If you have anything to upgrade this particular solution, you can also comment that. You can reach out me on my social media handles. I will be coming up with more such videos. So till then, this is Raj signing out.